everyone. Thanks for arranging this. I really appreciate the opportunity to present my work here. My name is Sateei, as you can see here. And today I'm going to present actually something that's outside my comfort zone. I usually work with virtual reality and those sort of user involvement related topics. So this is a first step in the direction I'm taking. I'm a first year PhD student, so it's still a very explorative phase, so to speak. So with that said, the mouthful of a title is Ontological Approach for a Recommendation System of a Requirement Tool. So in the case of a national standard framework for hospital design. So I'll get to it, but in a nutshell, what I will do is break it down in sort of slides, and you'll see how it all wraps up at the very end. So first off, we got the building standards for hospital project that is called PTS. That's short for Program for Technical Standards used in Sweden. And the whole story started off, we were very curious when I work usually with hospital projects primarily, and we saw why is that there is a lot, if not every region in Sweden is part of this program for technical standards, but they're not using the standard. Why is that? And that started off of our point of direction. And so what we try to explore in this paper is essentially how can an ontological understanding of this very distorted and this fragmented data information there is provide a better understanding for the design requirement. Primarily first for, which I will get back into later, but the property managers and the facility managers working directly with these classification codes and the design requirements, but also layer down, further down the line, also those who are directly responsible for the operational work, i.e. the medical staff, right? So, and the second point we try to raise and explore here is how can this understanding of design requirement of these hospital standards with their pertaining classification codes be translated to an increasement of involvement of end users, as I just mentioned right now. Because we try to understand not only on a facility and property manager level, but also down on the floor, so to speak, with the people who are actually working with providing healthcare. So the objective from that point of view is to create a conceptual and ontological based framework for this hospital standard, and this, we try to connect this now to a requirement specification. And you'll see in the slide I'll present next how we're going to achieve that. And then the second objective we have is, again, present an infrastructure with related syntax of how a potential algorithm could achieve some sort of graphical layout of a room. And this is more connected to the second point of involving the end users. So the first one is very much related to the property and the facility managers, and the second objective is, if anything, more related to the end users. So the methodological approach was, first off, was interviewing a qualitative approach with a semi-structured interview with 13 facility and project managers from 6 different Swedish regions. And these all range from sizes of the region. The very smallest regions of Sweden, it's a very long country, and the very biggest one, the capital of Sweden, Stockholm and Gothenburg. Next up, we analyzed the current interface of the hospital standard with its related classification system, and this is again connected to the first point that we interviewed these specific people because of their knowledge and because they directly work with these classification systems and these codes, hence why we interviewed them specifically. And from there, we gained a better understanding of how it actually all merged together or not, really. Because this was the first point of observation that we gained was, why is it not people using the standards? Oh, okay. And after interviews, we gained a bit more clarity as to why. So, and then lastly, we have, what I'm gonna present now is 2 different ontologies that build upon each other. So we'll have iterative presentation here. And first one is validating the design requirements using the classical OWL language for ontology, as well as a conceptual, which I just mentioned now, for the rule-based algorithm, which will involve the end users. So, first off, as you can see, it looks pretty much straightforward, but what this standard involved is not only the classification system, what we have here is the list of requirements with their connected classification codes. And what we all see here in this wall of text is essentially spatial components that belong in specific healthcare facility rooms. Everything from a surgical room to ICU unit to common areas where patients and medical staff are visited. So alongside that, we also, with these PDF documents, we also have 3D spatial components in Revit families that also are part of the bigger structure of the standard system. And so when we saw that, and this was really clear and emphasized in the interviews, which was very interesting. We saw a recurrent theme appearing throughout the interviews that was there is an overall sense of dissatisfaction and frustration among all the Swedish regions because their perception and experience is that this standard does not simply live up to the expectation of how real healthcare facilities actually are designed. Specifically, there's a lack of complex rooms in this. There's basically too many simple rooms, so to speak, common areas, and not so much surgical areas and robotical rooms, for example. And also, as well, there is the challenge of using it. So I talked earlier about user involvement on a medical staff level, that's one thing. But when the property managers and the facility managers also experience difficulties with using the interface, that's where the real issues appeared, right? Because they are the people working directly with these classification systems. And there was no incentives for them to actually work and use the standard. Hence them using their own internal resources instead of using the standard. So the first order of business was to break it down as simply as possible into, this is the first part of the ontology, we'll see the one that follows, but break down the facilities and the healthcare buildings that use the PTS standard. So the first order of business, again, is like we have the facility here, big grand building on its own, and then this is where the OWL language comes into play. We look at the facility, of course, contains some of, this is to describe the range of the class, some PTS rooms, right? Not all rooms in a hospital is necessarily connected to the standard. So that's where this comes in, but also it helps us with the distance that we need to know about certain rooms. It's not always that it's necessary, and if anything, that you have very specific rooms next to each other. For example, a banal example is, you know that in the regular toilets in an ICU unit, there should be a specific distance, and adjacent to these ICU units, you should have specific rooms. You don't have common areas right next to, for example, a surgical room, and so that sort of mindset. Next up, we break it down to the data properties, which are Boolean. Is it accessible to the room or not? Again, this goes back to what I mentioned earlier about being a semantic, being able to be compatible with a semantic reasoner, being algorithmic. And of course, the temperature for the specific rooms. Again, these are variables that are very important to know for very different rooms. They all vary. And the data properties further down. Then we can break out the room even further, the room itself, right? So we have the facility items that also is part of the room. And that's actually the class that I will break down in the next slide that will follow, that it contains all these spatial components. Also, the second subclass would be the operational unit item. This is again, spatial components are more related to the actual medical service that we provide. And lastly, we have the surface of the floor, like what type of floor is it, the floor surface. Again, to gain a better understanding how we break down the rooms into the ceiling, the walls, and the floors. So, I developed further like the item class to break it down even further. Again, this goes back to what I tried to emphasize in the first slide, is how we can make it more understandable so that everyone can partake in the development of the design requirements. So we break down the item into 3 different subclasses. We have the furniture, which in turn means the non-fixed furniture. It can be divided into that. The non-fixed furniture would be something as simple as chairs and hospital beds. And also there is the fixed furniture. That would involve parts that are connected to an electric outlet and those sort of furniture. Then, of course, the bed is one to end. If you have an ICU unit, you don't have one bed, at least not in Sweden. You have a whole range of beds, and hence the N to symbolize that. By the same token, we also have, for the fixed furniture, there's a whole array of different cabinets. And just for the sake of simplicity, I know there's more spatial components other than beds and cabinets, but just for the sake of describing how we're gonna go with the approach, we just took these. And next up is also the medical equipment, again, more related to the different medical equipment. I'm not a medical expert, so I'm not gonna try there, but this would be as simple as monitoring the heart rate of the patient, and those sort of spatial components. And least but not lastly, we have the installation. And this is more connected to what would be something, installations related to the subcontractors and those sort of involved actors in the design process. Again, going back to the theme that we try to involve all those involved in the design process of the healthcare facility. Now, what all this kind of leads to is this very conceptual, I emphasize conceptual syntax for this algorithm that we try to use here. So if we just break it down here, we try to see here that what I mentioned earlier is that we have the floors, we have the ceiling, and we have the walls. And these essentially dimensions variables help us when we input them into this algorithm, because specifically it helps us if we start off with the first point here. We start off with registering all sides. So take a very trivial example of you have a regular standard one-patient room. You know if you have that room, there is the bed there. The bed, in turn, should have a free logistical flow around it. That's where the sides of the spatial components come into play. Next up, we resolve these spatial relation constraints. Again, going back to what I talked about earlier, we know like the requirements for each side of the different spatial components and how that can perhaps help us when we essentially help out with the logistical flow of the different components. The bed is here, the window is here. We know it should be free space before the window. We know it should be free space around the bed. And then, very simply put, it can help us play out, and this is where the end users, the facility personnel also comes into play, with how they all understand this common language, right? We all know intuitively that, okay, can I place this like this or not? And that's where we have connected it at the very end to what I've written there, Y code, which is short for Virtual Collaborative Environment. It's a we are virtual reality-based system that it all boils down and connects to. That's how we try to here to involve the end users on a more tangible basis, rather than providing them with PDF documents. Yeah. So, long story short, ontological approach for PTS standard can help support better understanding for design requirements, not only for facility managers, but also the client side. And conceptually, the algorithm could perhaps potentially in the future help us to involve all type of actors, not only those working with requirements. And I'll just mention the last point here is that how we can perhaps study the basis of a recommendation system from this, and then learn how we can upload the IFC files when we upload them in each different project from each different region, upload them to the cloud, the IFC files, analyze them with a semantic reasoner, and then perhaps again conceptually, we can learn from each project. So that was for me. Thank you.